Welcome back to our series for HVAC vacuum dehydration. Today we're going to cover part 2, the flow. If you ever get the chance, I would recommend buying, finding, borrowing, reading somehow a book called Review of Vacuum for Service Engineers by Sanders and Williams. It's a fantastic book if you want to really understand vacuum and flow and how to make this system faster. So today, let's just start by what we typically see nowadays. Typical hookup, there's suction port hooked up to the suction side, high side of liquid side, manifold gauge set, our micron gauge, vacuum gauge, and then our vacuum pump. Pretty standard system, what you see. But let's talk about some of the issues we may have with that. First off, we're hooked up to our unit. We're hooked up to our unit, we're going through these ports right here. I don't know how well you can see it in the video, but right here we have these valve ports in here. And as you can see, this is only a 1/4 inch hose, a 1/4 inch hole that we hook to. And on top of that, this valve core takes up almost the entire size of that hole. Then when you push this button on the end, it just barely opens up. So that's an extreme restriction right off the bat, just pulling through this valve core. Then, you see most of the time, you'll have a low loss fitting. So these low loss fittings, we pull this apart, just the outer shell. If we unscrew this, we got our end piece with our rubber ends on it. We have another valve before we finally go through a hole. So we have another valve on top of that valve core. We have to go through the valve of our low loss fitting, which is again an entire separate restriction we have to deal with. So there's a restriction right there. Then we're going through these 1/4 inch hoses. These 1/4 inch hoses are made for pressure. So what we have to realize is when we're pulling a vacuum, the atmospheric pressure is pushing down in this hose and helping collapse it. Whereas when you're under positive pressure, it's pushing out. So this 1/4 inch hose in a vacuum won't be 1/4 inch. It'll actually shrink down some and be less. It can even permeate. It can actually pull air and moisture through hoses sometimes. So we're pulling through both these hoses, through those valve ports, through our low loss fittings, to our manifold gauge set, which is typical. But let's talk about that manifold gauge set. Here we've cut one open for you. And if you see where it's black inside of there, that's actually the size of the manifold opening. So that valve, this manifold set right here, that little bitty hole, that's about a 1/4 inch hole right there. So we're taking these two ports and we're pulling them both that little bitty brass hole. The good news is that one's not going to shrink down, but it's still another restriction. From there we pull down through 1/4 inch port. And then all of that vacuum is then now trying to pull through one hose or service hose. From there, that service hose, many times you'll see a low loss fitting on that as well. So it's another restriction. Finally, our vacuum gauge or our micron gauge. And then from there, we go through another hose. We now have a very long set of hoses. And then with another low loss fitting, finally before we get to our vacuum pump. So it's an extreme restriction on that. Even at the best pump, you're probably looking at about half a CFM of vacuum, just guessing. But you're definitely not getting the CFM of that pump. So let's just move away from that system. Let's talk about another way of doing it. There's many ways. We're just going to roll through a few of these examples. All right, so in this method here, we've changed it up a bit. Instead of having the low loss fittings, I've set this one up with valves. What's nice about this valve is we can open and close this valve, and being a ball valve, we have full flow. Now in this example, we're still pulling through those valve cores, which is definitely a big restriction. We'll talk about a way around that shortly. So with having these ball valves here, I don't have as much restriction as those low loss fittings. So that's a benefit. So by pulling through both of these sets, we're pulling up through a manifold set. This particular manifold set has a much larger bore. So I believe this one's a 3/8 bore, I can't remember exactly, but it's a larger bore than that 1/4 inch. From there, we're pulling through a much larger hose, and with that larger hose, we're pulling to our vacuum pump. So by having this larger hose, shorter hoses, it's much less restriction we have to deal with, plus less restriction through that manifold gauge set. The added benefit of this manifold is I have an extra port that I can actually pull my vacuum through my hose that's going to my charging tank. So this hose is going to be nice, clean, and pure when I get ready to open this valve and charge that refrigerant in there. The benefit of pulling this vacuum through and to my tank, for one, I don't have to worry about any contaminants inside this hose or any moisture that's going to get inside this hose. But when I do get ready to open my valves, if it's a pump down, I can actually break my vacuum with my fresh refrigerant first, so that when I take these valve caps off, I don't have to worry about moisture leaking in. I can actually have positive pressure pushing against those, so when I unscrew those, I'll actually have positive pressure. I don't have to worry about losing that vacuum I worked so hard for. Just one example for this setup. There's actually many ways of doing this same setup with many different types of manifold gauge sets. But let's first talk about a different way of doing it. Here's an entirely different way. With this setup here, we've used valve core removal tools. So I've actually removed the valve core entirely. And with the valve cores out, where this would normally screw to, I've attached my hoses directly to the end of that valve core tool. I've done one on the suction side, and I've done it again on the liquid side. By doing this, I've removed that valve core restriction entirely. From there, we're going through half-inch hoses. So I've got 2 half-inch hoses going to a T to my vacuum pump. This way, I'm pulling straight, unrestricted flow straight to my pump. Now I've eliminated a valve core. I've eliminated the low-loss fittings. I've eliminated the manifold gauge set entirely. I'm pulling straight to my vacuum pump. Unrestricted flow. This is an incredibly fast way of pulling a vacuum. On top of that, I have my micron gauge directly on my suction side, far away from my pump. Whereas this other example, I'm trying to use the micron gauge inside my manifold set that's notorious for getting clogged up or dirty when I'm using service work. This way I can keep my manifold set or my micron gauge, my vacuum gauge, completely isolated and clean. On top of that, on the liquid side, on the side port, I've attached a separate hose going to my new tank, my virgin tank of refrigerant. So as I'm pulling a vacuum, I'm actually pulling a vacuum through this hose straight to my tank. And that's very important because I'm not using any manifolds, so I don't have any extra valve to close. So when I'm pulling my microns, I pull my vacuum, I get my microns where I want them to be. I can then close off my valve cores, my valve core removal tool. These are actually micron rated. So when I close these valves off, I can actually watch for a rate of decay. And then when I'm ready, I can open my tank and I can actually put refrigerant directly into the liquid side to break that vacuum. Now I'm breaking that vacuum with refrigerant just enough so I have positive pressure. Now that I have positive pressure, I can take my vacuum gauge off and I can actually open my valves, take my hoses off, put my valve cores back in. It's all going to be positive pressure. I don't have to worry about losing any of my vacuum. I don't have to worry about any moisture contamination, oxygen or nitrogen contamination. This way it'll all be positive pressure when I get done. This is an extremely fast way of pulling a vacuum. Both hoses straight to the T, straight to the pump. My vacuum gauge is on the suction side. I have over here my refrigerant hooked up to the liquid side, ready to go. And I'm also using a valve here so I can control the flow of refrigerant. I don't want to put a lot of pressure against that micron gauge. I just want to put just enough to break vacuum, have positive pressure. That way I can open my valves without them leaking. And I can also put my valve cores back in and it's positive pressure pushing out instead of trying to pull contaminants in. It's a very effective way. This way is extremely fast. I can pull a vacuum down successful, get that moisture out of there, have a clean, tight, dry system. And there is another way. So this next way, with this setup here, it's a heat pump setup. So with this particular vacuum pump, we have set up with 3 different ports on it. So I have my valve core removal tool on the suction side, a valve core removal tool on the liquid side, going straight to my pump. Valve core is removed, no restriction. I have a 3rd port hooked up to my 3rd port of my unit, to my true suction line, and I have my micron gauge hooked up there. On the liquid side, I have my hose hooked straight to my tank, on the scale ready to go. I can pull a vacuum through this hose, it's all clean. I can valve off that hose as well for a pressure test, or a vacuum leak test, or a decay test, whichever you prefer to call it. Pull my vacuum very quickly, When I'm done with my vacuum, I can open my tank, break the vacuum with positive pressure for refrigerant, put my valve cores back in, I can hook my manifold gauge set up, I can open those valves, I can finish charging it. And there is also another way. If I had a refrigeration system or a very large system where I needed to pull quickly, they make a manifold vacuum set. With this set, I can actually add this vacuum manifold set to the top of this vacuum pump. And I have a whole lot more ports I can use to connect. Here I have an additional 2 1/2-inch hoses, another 3/8 hose, plus I still have space for 1, 2, 3, 4, 5 more service ports where I could attach. On a commercial system, if I attached a hose to every single one of those, this 8 CFM pump is actually getting its 8 CFM. Free flow, unrestricted. The benefit of this, I can actually close off and valve off my individual sections if I need. I'm not going to be using this set for a residential system, but still it's just another way to show that we can pull a vacuum without all these restrictions, and you will be surprised at how fast a vacuum will pull without having to go through all those restrictions. You'll see your microns drop down a whole lot faster. You'll see the benefits of that, and that saving time and having it done right. It's always a nice way. So I hope you enjoyed. Stay tuned for part 3 next week. Thanks.